Every snack we enjoy has a story hidden behind it. And today we're diving into one of the world's most beloved, the potato chip. At first glance, it may seem simple, just thin slices of potato fried until golden and crunchy. But the truth is, behind every bag of chips lies a fascinating journey. From carefully selected potatoes to cutting-edge machines to the moment you hear that satisfying crunch. It's a process full of science, precision, and a little bit of magic. So before you grab your next handful, let's take a closer look at how these crispy bites come to life. The journey of a Lay's potato chip begins far away from the buzzing factory floor, out in sprawling potato fields where the harvest season is in full swing. These aren't just any potatoes. They're specially selected varieties grown to deliver the perfect balance of starch, moisture, and flavor. Under the warm sun, specialized harvesting machines rumble through the rows, their powerful blades cutting into the soil up to 10 inches deep. In one smooth motion, they lift entire plants, roots, tubers, and all, from beneath the earth. As the potatoes rise from the ground, they tumble onto a vibrating conveyor screen mounted on the harvester. This ingenious mechanism shakes off loose dirt, stones, and plant debris, while allowing workers and machines to sort through up to 40,000 potatoes every minute. Nearby, trucks move in perfect sync with the harvesters, catching the freshly unearthed spuds as they roll off the conveyors. It's a finely tuned dance between man and machine, ensuring that not a second is wasted and not a single potato is left behind. Once full, these trucks make their way to massive storage hubs, built to handle hundreds of tons of potatoes every single day. Here, the harvest is temporarily held before the next stage, but the clock is ticking. Freshness is everything, and each potato's journey to becoming a Lay's chip has only just begun. From the storage hub, the freshly harvested potatoes make their way into one of the most advanced inspection systems in the snack industry, the optical sorting line. Here, the air is filled with the constant hum of conveyor belts and the rhythmic click of precision machinery. As the potatoes roll forward, they pass under a powerful array of high-speed cameras and laser sensors. In less than the blink of an eye, each potato is scanned from multiple angles. The system evaluates its size, checks for uniform shape, and even measures subtle changes in color that might indicate bruising or internal defects invisible to the naked eye. Every movement is calculated. If a potato doesn't meet the strict Lay's criteria, perhaps it's too small, oddly shaped, or has a blemish, the machinery springs into action. Agile pneumatic arms sweep away stray bits of soil and debris, while pinpoint air jets fire with laser-like accuracy, ejecting imperfect potatoes from the stream. The whole process is so fast that if you stood watching, you'd see a blur of motion but hardly be able to tell when a potato was removed. Those that pass inspection earn a place in cold storage, a crucial step to preserve freshness and quality. Workers gently transfer the chosen spuds into massive wooden crates, each capable of holding hundreds of pounds. These crates are then stacked inside a climate-controlled warehouse so vast it feels like stepping into a cool, silent cathedral of potatoes. The air is crisp, the lights are dim, and the temperature and humidity are carefully balanced to slow down sprouting and spoilage. This facility can store up to 40 million potatoes at once, acting as a reserve to keep the production lines running year-round. Depending on demand, some potatoes may only rest here for a week, while others could wait for months before their turn on the factory floor. But no matter how long they stay, their destiny is the same: to be transformed into the crispy golden Lay's chips we know and love. Once the potatoes leave cold storage, it's time for them to begin their transformation into chips. The first stage of this journey is a thorough cleaning, a process far more intense than simply rinsing them under a kitchen faucet. The potatoes are tipped from their crates onto a moving water flume, where a steady current carries them forward. The sound of rushing water fills the air as the tubers swirl and bump gently against one another, loosening clumps of dirt still clinging from the fields. As they float along, the stream guides them toward a set of rotating cylindrical drums lined with stiff brushes. These brushes spin at high speed, scrubbing the skins while a continuous spray of clean water cascades down. It's a careful balance, enough pressure to remove soil and surface debris, but gentle enough not to bruise the potato. Next comes the peeling stage. The clean potatoes roll into specialized peeling machines that use a combination of abrasion and precise cutting to strip away the thin outer skin. Some models use textured rollers to rub the skin off, others use blades that skim it away in delicate curls. In either case, the goal is the same: reveal the pale, flawless flesh beneath, ready for slicing. Any bits of skin that remain are removed by hand or with smaller brush units further down the line. By the end of this step, the potatoes glisten under the factory lights, perfectly smooth and ready for the next phase of their journey, the slicing room, where they'll finally start to resemble the chips we recognize. With their skins completely removed, the potatoes now advance along the conveyor toward the slicing station, a place where precision meets speed. Here, each potato is funneled into a specially designed chute that positions it just right before it reaches the slicing blades. These blades aren't ordinary kitchen knives. They're razor-sharp stainless steel discs spinning at blinding speeds, sometimes thousands of revolutions per minute. The moment a potato makes contact, it's instantly transformed into uniform, paper-thin slices. The sound is a soft, rapid shh as dozens of slices fall away in perfect consistency, each one no thicker than a credit card. Maintaining the correct thickness is critical. Too thick, and the chips will feel heavy and lack that signature crispness. Too thin, and they'll become too fragile and may burn in the fryer. To ensure perfection, the machine's settings are carefully calibrated and the blades are inspected regularly for sharpness. Once sliced, the delicate potato pieces glide down onto a mesh belt where a gentle stream of air separates any slices that might have stuck together during cutting. This ensures that every single piece is ready to cook evenly. At this point, they look nothing like the hearty potatoes that entered the factory. Instead, they already resemble the beginnings of the classic Lay's chips we know, pale and waiting for their golden transformation. Once perfectly sliced, the potatoes make their way to the heart of the process, the fryer. This massive stainless steel basin is filled with hot oil, shimmering under the bright factory lights. The temperature is carefully maintained, often hovering around 350 degrees, about 175 degrees, to ensure each slice cooks evenly without absorbing too much oil. As the slices slide in, there's an immediate sizzle, like a gentle rainstorm hitting a hot sidewalk. The moisture inside each slice quickly turns into steam, puffing up the potato just enough to give it that airy crunch Lay's is famous for. Conveyor paddles gently move the slices along, making sure none stay in one spot for too long. Timing is everything here. Too short in the oil, and the chips will be pale and limp. Too long, and they'll darken and take on a bitter taste. The journey through the fryer typically lasts only a few minutes, but in that short time, the transformation is dramatic, from soft, pale slices into golden, crisp chips. Before leaving the fryer, excess oil drains away, aided by a subtle tilt in the conveyor and a brief pause over a mesh section. The result? Chips that are crisp but not greasy, light but full of flavor. At this stage, they already look tempting enough to eat, but they're not quite ready for the bag just yet. The next step will turn them into the Lay's flavor you instantly recognize. Fresh out of the fryer, the chips are still warm and perfectly crisp. The ideal moment to lock in flavor. They move along a rotating drum which slowly tumbles them over and over. This movement ensures that every chip gets an even coat of seasoning. Inside the drum, fine nozzles spray a light mist of oil, not for frying this time, but to help the seasoning cling to each chip's surface. Then comes the magic, the powdered flavor blend unique to each Lay's variety. Whether it's the tangy punch of sour cream and onion, the smoky kick of barbecue, or the classic salty taste, every mix is carefully measured to the gram. As the chips tumble, the seasoning snow falls over them in a steady stream. The powder sticks instantly thanks to the warm surface and the light oil mist. It's a mesmerizing sight. Golden chips slowly rolling while a colorful cloud of flavor dust dances in the air. Quality control staff keep a close eye, making sure no batch is over or under-seasoned. By the time they leave the drum, the chips aren't just potato slices anymore. They've become lays, each one carrying the exact taste you expect the moment you open a bag. Once the chips are perfectly seasoned, they move toward one of the most critical stages, packaging. Even the best chips won't stay fresh for long unless they're sealed away properly. The conveyor belts guide them into a vertical packaging machine, where an advanced weighing system ensures each bag contains the exact amount promised on the label. Above the bags, large stainless steel hoppers release measured portions of chips. These fall directly into the forming bags, which are made from a special multi-layer film. This material isn't just for looks. It protects the chips from moisture, light, and air, which are the main enemies of crispiness. As the chips drop in, the machine heat seals the top in a fraction of a second, trapping in all that flavor and crunch. At the same time, nitrogen gas is added. This isn't to inflate the bag just for show. The nitrogen serves as a cushion, keeping chips from breaking during transport and preserving freshness for weeks. Finally, the sealed bags slide onto another conveyor, ready to be boxed and shipped to supermarkets, vending machines, and corner stores across the country. From here, it's just a matter of time before they land in someone's hands, waiting for that satisfying first crunch. Once the freshly packed chips are boxed, the next step is getting them from the factory floor to store shelves as quickly as possible. Speed is crucial here. Although the packaging keeps chips fresh, Lay's prides itself on delivering them to customers while they're at peak flavor and crunch. Forklifts carry large stacks of sealed boxes onto trucks waiting at the loading docks. These aren't just any trucks. Many are climate-controlled to prevent temperature swings that could affect the product's quality. The logistics team works like clockwork, planning the most efficient routes to reach thousands of destinations. Some shipments head to massive distribution centers, where they'll be sorted and sent to supermarkets, gas stations, and vending machine operators. Others go straight to local stores for faster restocking. Every delivery is timed so that chips never sit too long in storage. From there, it's only a matter of hours or days before someone grabs a bag off the shelf. The journey from potato in a farmer's field to a snack in your hand might seem long, but for Lay's, it's a finely tuned process, one that runs 24/7 to keep that irresistible crunch within arm's reach. Even though Lay's chips might seem like a small everyday treat, their story is anything but small. It's a story that begins in the soil, passes through generations of farming knowledge, blends tradition with modern innovation, and finally arrives in your hands as that unmistakable crunch. Behind each bag, there's a network of farmers, engineers, food scientists, quality inspectors, and countless other people who care deeply about their work, even if you'll never meet them. They're the reason you can count on that same flavor whether you're eating Lay's in New York, London, or Tokyo. So the next time you hear that gentle pop as the bag opens, maybe you'll see it differently. Not just as a snack, but as the final chapter of a journey that's traveled thousands of miles and touched hundreds of lives. And in that moment, you're part of the story too. Every day, millions of cakes are baked, decorated, and enjoyed around the world, but few people ever see what happens before they appear in a bakery display. Inside modern food factories, advanced machines and skilled workers operate in harmony to transform basic ingredients into picture-perfect desserts. In the next few minutes, we'll take you deep inside an automatic cake production line, following each step from the first scoop of flour to the moment the finished cake is sealed and ready for delivery. The journey of cake making in a factory begins with the simplest of ingredients: flour, sugar, eggs, and milk. But at an industrial scale, this process looks nothing like what happens in a home kitchen. Specialized robotic systems can crack and separate hundreds of eggs every single minute. Yolks and whites are automatically divided with precision, then funneled directly into enormous mixing tanks. Meanwhile, flour and powdered sugar are weighed by digital sensors, ensuring the exact ratio is delivered at the right time. Inside giant mixers, the dry and wet ingredients finally come together. Each batch can handle hundreds of pounds of batter, guaranteeing a smooth and consistent blend. The speed of the mixing blades is carefully controlled so the batter becomes both silky and airy, perfect for cakes that will rise evenly in the oven. Once the batter reaches perfect consistency, it flows through stainless steel pipes into the portioning system. Here, automated nozzles release just the right amount into each cake mold. Every drop is calculated too much and the cake overflows, too little and it won't rise evenly. The molds themselves are pre-treated with a thin layer of food-grade oil to prevent sticking. Depending on the cake type, the molds may be circular, rectangular, or designed for individual snack cakes. In some factories, the molds pass through a vibration platform for a few seconds. This helps the batter settle evenly and eliminates any air pockets, ensuring a smooth texture in the final product. The filled molds then move steadily along the conveyor toward the baking ovens. As the molds enter the tunnel oven, a wave of heat begins transforming the batter into fluffy cakes. Industrial ovens here often span over 30 meters in length, using a combination of convection and radiant heat to ensure even baking. The temperature is carefully set too low, and the cakes will be dense, too high, and the surface will brown before the inside is fully cooked. Internal sensors constantly monitor both air temperature and the cake's core, adjusting the heat in real time. While inside the oven, the batter expands as trapped gases from the leavening agents push upward. The golden crust forms naturally as moisture evaporates from the surface. By the time the molds reach the end of the oven, the cakes have doubled in height, their aroma filling the air. Fresh out of the oven, the cakes are far too hot and fragile to handle. They travel along a spiral cooling conveyor and upward or downward winding track that can be over 100 meters long when uncoiled. This design saves floor space while allowing enough time for the cakes to cool naturally. Cooling is essential. If packaging happens while the cakes are still warm, condensation will form inside the wrapper, leading to sogginess and mold growth. The airflow in the cooling area is carefully regulated to avoid drying out the cakes while removing excess heat. By the time they reach the end of the cooling spiral, the cakes have settled into their final shape and texture, ready for the next stage filling and decoration. Once cooled, the cakes move to the filling station where precision meets creativity. Industrial injectors, equipped with multiple nozzles, pierce the cakes and pump in measured doses of cream, chocolate, or fruit jam. The pressure and timing are carefully calibrated to prevent overfilling, which could split the cake's outer layer. Next comes the decoration line. Here, rotating icing heads and automated piping arms drizzle silky frosting across the surface, sometimes forming intricate swirls or straight elegant stripes. For special editions, additional toppings like chocolate shavings, crushed nuts, or colorful sprinkles rain down from overhead dispensers. Even with automation, human workers stand by for quality checks, making sure every cake not only tastes perfect, but also looks worthy of display. The journey of sweetened condensed milk begins long before it reaches your kitchen. Fresh raw milk arrives at the factory in large stainless steel tanker trucks, directly from carefully selected dairy farms. Each truckload contains thousands of liters of milk, chilled to preserve freshness during transport. Before unloading, quality control teams run a series of rapid tests, checking temperature, fat content, and purity to ensure the milk meets strict industry standards. Only after passing these tests is the milk pumped into massive refrigerated storage silos, ready for the first stage of processing. Once inside the factory, the chilled raw milk is pumped into massive stainless steel tanks, each capable of holding thousands of liters. From here, it moves into the separation stage, a crucial process that determines the final richness of the condensed milk. High-speed centrifuges, spinning at thousands of revolutions per minute, apply intense force to split the milk into two components, the rich cream and the lighter skim milk. This separation is not just about removing fat, it's about creating the precise base for the product's signature texture. Technicians monitor this process closely, adjusting the spin speed and temperature to achieve the exact fat content specified in the recipe. Too much cream and the condensed milk could become overly thick and heavy. Too little, and it might taste watery and lack the velvety mouthfeel consumers expect. Once separated, the cream and skim milk are recombined in carefully measured proportions. This standardized milk is essentially the blank canvas on which the rest of the process will build flavor and sweetness. At this stage, the milk still tastes fresh and mild, almost like the milk you'd pour over cereal at home. However, its composition has been fine-tuned with scientific precision, setting the stage for the transformation that will follow in the heating and concentration phases. Every batch must match the factory's quality standards exactly, because in large-scale food production, consistency is just as important as taste. The standardized milk now enters the heating phase where the transformation into condensed milk truly begins. The liquid is pumped into large enclosed vacuum evaporators, towering metal chambers designed to remove water without burning the milk. Inside, steam circulates through a network of heated pipes, raising the temperature of the milk to around 60 to 70 degrees. Because these evaporators operate under reduced pressure, water in the milk can boil off at much lower temperatures than normal, preventing the proteins from scorching or developing a cooked taste. As the heat works its magic, the volume of the milk begins to shrink dramatically. Nearly half of its water content will be removed during this stage. Operators monitor the process carefully, checking both the thickness and the total solids content, a measure of how concentrated the milk has become. These readings are critical. If the milk is evaporated too much, it can become overly dense and difficult to process later. If it's too thin, it will require extra cooking time, which could affect flavor. The atmosphere inside the factory during this step is unique, warm and slightly sweet as the natural sugars in the milk start to become more pronounced. Technicians frequently take small samples to check texture, using both instruments and simple visual inspection. By the time the heating phase ends, the milk has taken on a noticeably richer color, a creamy off-white, thicker than fresh milk but still pourable. This concentrated base is now ready for the key ingredient that will give condensed milk its signature sweetness: sugar. With the milk now concentrated, it's time to introduce the ingredient that transforms it into sweetened condensed milk, pure granulated sugar. Large bags or automated feeders pour precise amounts of sugar directly into the warm milk, where it dissolves almost instantly thanks to the elevated temperature. The ratio is carefully calculated. Too little sugar, and the condensed milk won't achieve the right sweetness or preservation effect. Too much, and it will crystallize over time, ruining the smooth texture. The sugar serves two purposes. First, it adds the rich sweetness people expect from condensed milk. Second, it acts as a natural preservative. By increasing the sugar concentration in the liquid, the water activity is reduced, a scientific way of saying that bacteria and mold have a much harder time growing. This is why sweetened condensed milk can last for months, even without refrigeration before opening. After the sugar is added, massive mixing paddles or high-speed agitators stir the thickened milk continuously. This ensures every grain of sugar is completely dissolved and the mixture becomes silky and uniform. Technicians check the viscosity by dipping in a special rod. The way the milk coats the metal tells them if the texture is right. They also measure Brix levels, which is a reading of sugar content, to confirm consistency from batch to batch. Visually, the transformation is striking. The milk becomes even thicker with a glossy sheen that catches the light under the factory lamps. If you've ever opened a can of condensed milk, you've seen that slow ribbon-like pour. This is where that texture is born. By the end of this stage, the product is almost ready for cooling, but before that it must pass through one more crucial step: pasteurization, to ensure safety and shelf stability. After the thickened, sweetened milk reaches its final consistency, it must be cooled quickly to preserve its creamy texture and prevent crystallization. Large stainless steel cooling vats bring the temperature down in a controlled manner, ensuring the product remains smooth and rich. Once cooled, the condensed milk flows into automated filling machines. These machines can fill hundreds of cans or tubes per minute, each precisely measured to the correct weight. Lids are sealed tightly to keep out air and moisture, which could spoil the product. For tubes and pouches, heat sealing is used to create airtight packaging. Throughout this process, quality control teams inspect random samples, checking for proper texture, flavor, and sealing integrity. This ensures that every unit leaving the line meets the brand's high standards before it's packed for shipping.